Another theorem here concerning invertibility of matrices. If A and B are invertible matrices of the same size, then AB is invertible, and then AB inverse is equal to B inverse A inverse. So I want us to write a proof to this one. What it means is that A is invertible, right? It's a square matrix. B is also a square matrix. They have the same sizes, maybe a 4x4, 5x5, whatever you can think of. But A inverse exists, right? We have A and then A inverse. And then we have B and then its inverse also exists. They are both invertible. Our main challenge here, the first part, is to show that AB is invertible. Now, to show that AB is invertible, what we can do is to try to find some matrix such that when you multiply by AB, or when you post multiply or pre-multiply by AB, you're going to get the identity matrix. So my claim is that I'm going to say that AB, okay, I'm going to multiply it by a matrix. I'm going to choose this because the B part also says it. So if I can use a B to prove, the A, one would ask, what if I didn't know that AB inverse was B inverse A inverse? I can choose to just multiply this by B inverse A inverse and see what happens. Okay, when I multiply that, what am I going to get? I'm going to get A, and I can write it B times B inverse and then A inverse again, right? And this side is going to be A, and then B times B inverse is going to give me the identity matrix, and then A inverse, right? Now A times the identity matrix will still give me A. Okay, so this whole thing is going to be A inverse, right? And what is A inverse? Is equal to the identity matrix. So I know AB times B inverse A inverse has given me the identity matrix. Now that is not enough. We have to also show that B inverse A inverse times AB should be the identity matrix as well. So this is also going to be B inverse, similar thing we did for that. And we know that A inverse is the inverse of A, so it means A inverse A is the identity matrix, and then any 10 times the identity matrix will give you the same thing. So I'm going to get B inverse B, and that's still the identity matrix. So you realize that AB times B inverse A inverse is the same as B inverse A inverse times AB, right? And that gave us the identity matrix. So it means AB is invertible, and then by the B, the only thing we have to say is that what is AB inverse? That is, what is the inverse of AB? And what we were able to claim is the same as B inverse A inverse. Okay. So that's the proof that if you can show that indeed that something exists, so that the product of them post multiply and then pre multiply. What I mean is, you first multiply this way, you should get the identity matrix, and then you go by that way as well, you should get the identity matrix. Then we can say that that particular matrix we have is the inverse of the other, right? So that is how the proof goes about. Maybe in our next discussion, I'm going to take more calculation problems to solve about. Okay, see you.